Hi guys, Mr. Gilmore here. So back at you with another one of these transformational geometry or transformation geometry uh, classes. Today what we're going to be looking at is axial symmetry. So what axial symmetry is what we're going to learn today. Now, axial symmetry, you've probably already heard the word symmetric, which pretty much just means that it's the same on one side as it is on the other. So let's just take this piece of paper. If I fold this piece of paper over, right, we can tell that there is clearly a line along the piece of paper where one side is the same as the other, right? So this side is exactly the same as this. Similarly, we can fold it lengthways, can't we? We already know that. So you can fold a piece of paper lengthways, and you can see that there's another line where it's symmetric. Now I haven't folded this perfectly. Try that again. There we go. That's a little bit better. So I can look at this and I can go, okay, there's a line along this page, like so, where either side is symmetric. There's another line along this page where either side is symmetric. This side is the same as this side. And we call these axes of symmetry. So like a x and y axis, an axis really just a line along which we measure things. Here we've got two axes of symmetry, two side, kind of like two lines that we can draw through the object that will work to kind of mirror both sides. Now, if we look at kind of people's faces, most people's faces are roughly symmetric, and I know that this smiley face isn't a perfect representation, but you can see, okay, most people, we've got two eyes, and even if I added details, two ears, same side of the face, we've got a nose, which again is relatively symmetric. Most people have roughly symmetric faces. Now, obviously, there's always going to be slight variations, but for the most part, people are symmetric. And not only are their faces symmetric, for the most part, people entirely have one axis of symmetry all the way down the length of their bodies. And that's actually true for most mammals. Like if you look at the top of a cat, right? You go, okay, wait a second. There's an axis of symmetry along there. Most mammals are symmetric, as are a lot of other living things. So ants, for example. Look at an ant. It has a line of symmetry down its center. So most creatures on Earth are symmetric, okay? But so are a lot of shapes. So here we have a square. So like the rectangle, you can see there's an axis of symmetry here. There's an axis of symmetry here. Can you think of another two? Maybe if you did it diagonally. Didn't do that perfectly, I'll be upfront here. But you can see, wait a second, there's other axes of symmetry. If I folded this over along this line, you'd see that these two ends would meet. If I folded this over along this line, you'd see the two ends meet. Other points of symmetry, most flags, so the Irish flag, I tried to use a green crayon, this has not come out well. Most flags are symmetric in some way, so the French flag, Italian flag, what have you. The British flag, for example, that's actually got its two lines along it that are symmetric anyway. If I look at an equilateral triangle, you can go, wait a second, there's a line of symmetry down the center. There's a line of symmetry this way. There's another line of symmetry this way, isn't there? You can see, wait a second, that cuts that in half perfectly. That cuts that in half perfectly. That cuts that in half perfectly. For an isosceles triangle, again, you can see axes of symmetry. For like a inverted military insignia, you can go, wait a second, there's an axis of symmetry there. Even for the letter B, you can go, wait a second, there's an axis of symmetry along here. Loads and loads of objects in our world are symmetric. Can anyone think of maybe a shape that has infinitely many axes of symmetry? Just think about it for a sec. Did anyone come up with a circle? You can look at a circle and go, wait a second. Oh, made a little bit of a blunder there. This isn't going to be the best circle in the world, given that I lost my place there. Okay, so this is quite a poor compass, but what have you. So we're looking at this circle and we can go, wait a second, if I go along any line going through the center, that's going to be another axis of symmetry. Circles have infinitely many axes of symmetry. It's just crazy. So girls, just as homework, could you give a try at pages 379 and 380, questions 1 through 6. Most of them are just asking, does this have an axis of symmetry? If so, how many and whatnot. Okay, thank you very much, girls. Have a lovely day.